Good evening. Good evening, people. Okay. So we have started with mathematics for quantum mechanics. We are supposed to complete that chapter in this particular lecture. So in fact, we will be completing and then also we'll be also starting with the next part of the chapter. Okay. In the last class, we had learned, what did we learn? We learned after linear independence, we started with dimension. We learned the Dirac notation. We learned the properties of bracket notations, and we learned inequalities, two kind of inequalities. So there's a comment here, sir. I'm very happy today you are taking two classes. Achha, you guys already noticed it. Nice.
Yes, sir.
Yes, sir.
Okay.
Very happy.
So, yeah. Actually, I came to know that sir is not taking the class. I'm like, hence I'm here. I can take both the lectures. Anyway, we have so much of less time. So I'm like, whatever class I can get, I'm going to speed it. So okay. So we are going to take both the
The whole
lectures.
night is yours.
Hanji?
I'm pleased the whole night is yours, sir. Today's
Voice is breaking. The whole is?
the whole night is yours only.
So the whole evening is mine. Not night. That's okay. No problem. So let's get started, people. Proceeding ahead. किसका sound रहेगा चालू? Okay, let me note it up. Okay. Please give heading. Orthogonal states, people. Orthogonal states. Are you aware of the word orthogonal? You may have come across this in mathematics or somewhere in this, people.
Yes, sir, in chemistry also.
So what is orthogonality? Whenever two things are perpendicular, you call them orthogonal. Simple.
Yes,
That's it.
sir.
That's it. So like if two vectors are perpendicular to each other, you call them their orthogonal. Their dot product becomes zero. A bar dot b bar. Like for example, in circular motion, you can say the tangential velocity and the centripetal force are orthogonal to each other. Their dot product becomes zero. A bar dot b bar is ab cos theta. Ab cos 90. Cos 90 is zero. It becomes zero. So orthogonal states basically you can say in our quantum mechanics that two ket vectors, let's say for example psi vector and phi vector, okay, are orthogonal if their scalar product is zero. That's it. If the value of psi phi is zero. It's just like a bar dot b bar. That should be zero. Okay. Next. Now, importantly, those orthogonal sets, which also obeys, you can say this thing, or which also satisfies anything, whatever language you want to use, which also satisfies individual normality. Normality means the normalization condition. The value of psi should be 1 people. Last time we learned what is normalization. The value of psi equals integration of minus infinity to infinity of psi star psi dx. All space, over all space. That value is supposed to be 1 basically. Okay. So which satisfies individual normality are called orthonormal states. Orthonormal basically means orthogonal plus normalized. Orthonormal basically is nothing but combination of two words, people. The first word is orthogonal plus they are individually normalized also, plus normalization. So it means that the value, if suppose psi phi is 0, it means they are orthogonal to each other. However, the value of psi individually will be 1 and the value of phi individually will be 1. People, this is writing it right now. I dot I is 1, j dot j is 1, but I dot j is 0. So if two vectors are perpendicular, it's dot product I again. A bar dot a bar. I dot I, that is basically nothing but a magnitude of phi, which is 1. Okay. So if at all psi becomes 1 and phi becomes 1 and psi is 0, or you can say phi is 0. Okay, whenever this happens, basically, what do you call them? You call them orthonormal. Tell me if you have any questions. So this is normalization condition, okay, and this is the orthogonality condition. So orthogonal plus normalization are called as orthonormal. Very important technical words to be used throughout the quantum. Okay. Clear?
Yes, sir.
Let me wait writing.
Yes, sir.
Wait, I will immediately take a question on this. I have one. There was one.
Sir,
Yes,
sir.
can you tell me, sir, what is the meaning of normalization? That is just I am asking.
Normalization basically means that you are ensuring the probability of finding that particular function becomes 1 in that particular region.
That means we can find the particle.
We can find the particle. We can find this state. We can find the state for sure if you want to find, but in that particular region. Okay. And also, just give it some time. Like you will understand this better and even better as we proceed. Like as we will reach 1D, 2D harmonic oscillators, when we apply those application problems, then you will understand these things even better. Right now, we are only understanding language. So like it's like when we learn ABCD, EFG, students are asking, sir, why are we learning BCD and why P comes up, like why Q comes after P or whatever. We understand these things better as we learn English. Okay. But okay.
Yes, sir, I think so.
No problem. I don't hope. Believe so.
Okay, sir.
Yes. Proceeding. Believe. Proceeding. Let's take a question. So they have given us that phi 1 and phi 2 are orthonormal functions. So as soon as an exam, whenever you will read orthonormal, what you need to understand, first of all, it means phi 1 and phi 2 individually. Like if you multiply them together, answer will be 0. Phi 1 and phi 2, multiply them together, answer will be 0. But if you multiply phi 1 with phi 1, answer will be 1. And if you multiply phi 2 with phi 2, answer will be 1. That is the first thing we understand immediately. Okay. Next, they are asking find value of n, which normalizes the function. They have given your function, very interesting question, n into phi 1 plus 2i phi 2. Beautiful. So function is given to us. They are asking now this function should be normalized. Okay. So basically the value of this in all space should become 1. If you integrate this over all space, then it should become 1. Okay. And we want to find the value of n such that perspective. Let's do that. How about this? Your voice is breaking. No, it's still breaking. Try again. I heard phi 1, phi 2, but I couldn't hear beyond that. Then we good.
Yes,
Let's try and solve this.
Yes,
Okay. Sir, is iota in expression? Iota is there. Yes. This is a complex. This is a complex of iota. Absolutely, it's there in the expression. Okay. Yes. Let's write the ket vector of f. What is ket vector f? It will be n is constant. It is ket vector phi 1, okay, plus 2i into ket vector phi. I'm just writing everything in ket vector format. But if you write this in bra vector format, what will happen? N will remain n, no problem. Phi 1, that will become phi 1, that's fine. But what will happen to this? 2i will become minus 2i.
Minus 2i.
This is conjugate, and hence I have taken this problem purposely so that you notice that whenever you have a complex number, you need to remember bra vector means you are taking conjugate people, you have to make it minus 2i very immediately. And then phi 2 will remain phi 2. But you have to make it bra. That's fine. And now what I have said is f should be normalized. F is normalized. They mentioned it means the value of f with itself. The scalar product of f with itself, that should be 1. This is the meaning of normalization. So let's calculate. Multiply this and this. Simple. Okay. So n and n will become n square, and then we have to multiply this term with this term. Okay. So we have to multiply phi 1 minus 2i into phi 2. This into we have to do phi 1. We have to do phi 1 plus 2i into phi 2. This whole value should be 1. Copy, please. Don't hesitate to tell me your questions. Okay. This all may be very new to you, but it's very scoring, people. I'm telling you already. Quantum is very scoring, and I'm trying to take it as slow as possible.
So we are taking bra vector first and then ket vector.
Oh, yes.
Okay.
See, a normal expression is always a ket vector expression. Normal means ket. Conjugate is bra, right?
Okay. Okay. Yes, I
So that whatever expression we have, that is always a ket vector expression, always.
Yes.
Okay. So here we don't have to integrate this expression. No, because it's not a function. It's not x, y, z or as such. They have not given the value of phi in terms of x, y, z. Have they given us the value of phi 2 in terms of x, y, z? Directly, ff is 1. Okay. So what do we have further? So this becomes n square into, now multiply phi 1 with phi 1. Okay. So we have phi 1, phi 1. Next. Then multiply phi 1 with 2i, phi 2 p2. So I have got plus 2i and I have got phi 1, phi 2. I have got phi 1, phi 2. Okay. Then multiply phi 2 with phi 1 p2. So I have got minus 2i, phi 2, phi 1. I have got minus 2i, phi 2, phi 1. Okay. And then multiply this term with this term. Now be very careful. Okay. Minus 2 into minus 2, that's minus 4. Then I into I, that's I square. And then phi 2, phi 2. Phi 2, phi 2. Okay. This is 1 p2. So we have n squared. What is phi 1, phi 1? 1. 2i. What is phi 1, phi 2? 0. Minus 2i. What is phi 2, phi 1? 0. Minus 4. I square is minus 1. What is phi 2, phi 2? 1. Also normal. Phi 1, phi 1 is 1. Phi 2, phi 2 is 1. But phi 1, phi 2 is 0. Phi 2, phi 1 is also 0. So we have got n square into 1 plus 4. This is 1. We would have got n square into 5. This is 1. We would have got n square is 1 by 5. We have got the normalization condition, and is 1.25 people. The value of small n should be 1.25.
So plus minus not required.
Absolutely, plus minus. Yes, thank you.
Okay. Not inside.
Plus minus into plus minus into 1.25. Okay, people.
So really say well understood.
Thank you. Yeah. See, I'm trying to follow Zetli, like I said, but Zetli has only theory. Like they don't have these little numericals between. It is just I'm trying to basically, what is that word? Amalgamation, right? Basically merging up of many.
Yes, amalgamation.
Chemistry word. Okay. Proceeding ahead. Next people. Tell me if you have any questions, okay? There we go. So in the last class, just like you had asked me, please remember the value of psi phi, something like this exists. Okay. Basically, a bra vector multiplied with a ket vector exists. Similarly, a ket vector can be multiplied with a bra vector. This is also fine, people. This is also defined in quantum, no problem. However, we don't have any such definitions where you can multiply a ket with a bra with a bra or ket with ket. These things don't exist in quantum physics. Okay. Basically, these values are prohibited. Phi psi is not allowed. Similarly, psi phi is also not allowed. Psi phi is also not allowed. The point is, a ket cannot, a bra cannot be multiplied with a bra. A ket cannot be multiplied with a ket. But a bra and ket can be multiplied. A ket and bra can be multiplied. These two are prohibited. Okay, that's important. And just in case they ask you an exam, very technical, but if they ask, find projection of psi onto phi. People many times order really matters. I hope you have realized that. Because see, here it matters that if we are writing phi first or psi first or psi first or phi first, because they are not equal, we have learned the distribution number. They are not always equal. They were equal only conditional.
Yes.
Okay. So here the order really matters. So projection of this onto this, what is the meaning of this? It is actually scalar product only. Find the scalar product of this with this. The question is who should be multiplied where? That's important. Okay. So whenever they ask projection of this onto this, basically it means that psi already exists. You have to throw, and phi already exists. You have to throw psi on it. You have to throw psi on it. Projection of A on B, A is on the right side, B is on the left side. People. So it's always projection of right on left. People. It's always right on left. So remember that. Whenever you write projection word, it means you have to take conjugate of this. You have to take conjugate of this, and you have to multiply it with the ket vector of this. This is very technical language, but just in case if they ask this, because order really matters. So either calculate phi psi. This is also equivalent equal to, if you remember, psi phi the whole star. Both are one and the same thing. Tell me if you have any questions. So this is done. Okay, people. Any questions until here? Great. So with this, we complete the section of mathematics for quantum mechanics. MFQM is done. But before we start with the next chapter, whom I would like to call POQM. We are not yet starting with this. The name of the chapter is Postulates of Quantum Mechanics. Before that, again, there is a bridge I want to cover. So all the chapter will be using operators people a lot. So let's spend some time in understanding operators. We can give a small chapter in between, giving operators. Achha, listen. So if time was not a problem, I would have taken 2 to 3 lectures on operators. Operators are really important for JEST and DI actually. In JAM, operators are not exclusively used. Okay. Basically, relationship between operators and everything, it's not exclusively used. It is used only in problems that we will be doing later in postulates and application of Schrodinger equation and everything. Okay. So I'm not going to take 2 3 lectures on this. There's a small bit of lecture which I require throughout the quantum mechanics. Otherwise, it's a long topic. Again, exactly can be used for a good reference if you want to. Later after your exam, you can go through the book. As of now, we'll just learn the things which are important. Okay. So to start with, please be writing operators. And So the operator is basically like derivative, just like we learned in the first class. We also got linear operator. That was linear operator, that we learned in the first class. Derivative was a linear operator. Then we had I think we took another operator which was secant, 2x. So that was also a linear operator. So operators are basically which you can apply on a function. You can like c cap. C cap you had applied on u and you had got 2u basically. So c cap was an operator there. Now it could be anything. It could be 2. It could be d by dx. It could be integration. It could be a matrix. It could be anything. The point is when you apply an operator on a function, here what is a function equal? Wave function, psi1, psi2, psi3, which is basically a ket vector. Psi1 ket vector, psi2 ket vector, all the ket vectors. So if you apply any operator c cap on the operator, on the function, then you get the same function back. You get the same function back with some additional value. You get with some additional value, or you can say or you can just say you are getting another function. Suppose you are getting another function, but belonging to the same vector space. That is what you can say. So let us just write that when we apply operators, okay, on a ket vector or a bra vector, on a ket vector, okay, it makes it a new ket vector belonging to the same vector space people. It makes it a new ket vector. Like derivative of sign, it makes it cos people, something like that. It makes it a new ket vector, however, belonging to the same space, belonging to the same vector space. Okay? Take a look. So it's like
Hello, sir.
Is sir audible to you?
I am not also hearing, sir.
मुझे तो सुनाई दे रहा है.
Is sir in the meeting?
Is
anybody audible to sir?
anybody audible or are you hearing, sir?
Yes.
What is going on?
I don't know.
शायद नेटवर्क प्रॉब्लम है.
गुरुजी आते हमारे.
न्यू ईयर छुट्टी पे चलेगा.
अरे चुप कर, sir is also hearing on. Maybe.
सर का वाईफाई गया.
भैया भाई जयपुर से ले रहा है क्लास कोई.
अब जान ले सबका आइडेंटिटी जान ले कि कौन-कौन तुम्हारा स्टेट में है और नॉट.
सर बोल रहे हैं प्लीज डोंट एंड अर्ली क्लास.
Okay.
Please do not hesitate.
I have left the meeting and rejoined, but the same thing is happening.
एक दो मिनट वेट कीजिए.
आकाश को होस्ट बना दिया, वही पढ़ा देगा.
सर रिजॉइन करेंगे. मैम बोल रही है स्टूडेंट को 1-2 मिनट का वेट करने के लिए बोल दीजिए.
ये तू तो पढ़ा लग गया यार.
हरियाणा से है क्या भाई?
आकाश का स्टूडेंट है.
लगता है आज की क्लास तो गई.
Keep silent.
Okay.
पेशेंस रखो.
Yeah, all of you are preparing for the exam 22 or 23. Anybody is here?
22.
Somebody is here for 23. Please speak up.
भाई हम तो 22 भी कर रहे हैं.
Thank you for letting me know.
भाई थर्ड ईयर कोई थर्ड ईयर में है यार बीएससी में.
Yes, I am.
हाँ फाइनल ईयर तो मैं भी हूँ.
भाई थर्ड ईयर की तैयारी कैसी चल रही है तुम्हारी?
तो गया वो गया काम से.
बिल्कुल गए यार. कोई बात नहीं 60% कोर्स आएगा. आशा करो आशा.
किसने नॉन मेडिकल लिया क्या?
नॉन कॉलेज से कौन है भाई यहाँ पर? कोई नहीं.
नहीं नॉन मेडिकल मतलब फिजिक्स केमिस्ट्री मैथ तीनों.
हाँ तीनों ही हमारे पास.
हाँ तीनों लिए.
सबसे बेकार लगती है नॉर्मल केमिस्ट्री.
ये सब भी रिकॉर्ड हो रहा है ना? ये रिकॉर्डेड क्लास में दिखा जाएगा. उसमें दीजिएगा।
हाँ
अब क्या डरते हैं यार, हमें कोई नहीं जानता।
तेरा नाम लूंगा।
हमारे तो कॉलेज उसमें बोलते हैं तो
एक जैनब सर की बात छोड़ के हम लोग क्वांटम मैकेनिक्स पर डिस्कस करते हैं today।
इंस्टाग्राम पर वो रिक्वेस्ट भेजी थी, ये कौन है, उनको क्या पता कौन है, एक्सेप्ट करे तो कर लो।
वेस्ट बंगाल से कोई है क्या यार? बंगाल।
ओडिशा से उसके पास।
ओडिशा से।
ओके ओके।
और कौन ओडिशा से?
भाई हम तो इंडिया में भाई,
हम कौन सा
हम लोग का
क्या?
पाकिस्तान से रहते
हम
हैं
भी
क्या?
इंडिया से ही हैं।
हम इंडिया। सर नहीं है मीटिंग में, तभी तुम बोल रहे हैं, मैं तो बोल सकता हूँ भाई।
तो किसी के आईआईटी बेटा रैंक से लग जाएगा तो बॉम्बे आईआईटी चूज करना है, वहाँ जाके जन्म सर मिल लेना और फ्रेंड को चुन लेना इस क्लास में जो जिस दिन है।
मुश्किल लग रहा है वैसे तो।
मुझे मुश्किल लगता है, समझ नहीं आ रही क्या प्रोसेस है।
अरुण आपकी आवाज बहुत
इनका आवाज इतना कम क्यों है भाई?
आवाज आ ही नहीं है।
तो मोबाइल
इसके
की
गले में सेंटर प्रेस कर दो।
क्या कोई दिल्ली साइड से है क्या?
दिल्ली में लगा गया, ओनली इंडिया से हम यार,
हम लोग एक है ना?
हम भारतवासी हैं।
सर आगे
क्या भारतवासी चल रहा है?
सर भारत बहुत कुछ चल रहा है सर।
अच्छा, अरे सुनो, क्या है यहाँ पे लाइट तो है, Wi-Fi. I'm sorry, I cannot speak in Hindi. I was saying that we do have electricity here, but I'm not sure Wi-Fi is out. I tried to connect to the Wi-Fi cable company. They are like, sir, I have refreshed from my end, see if it works, but it is still not working. So right now I'm working on hotspot, but connectivity of hotspot is full. It is showing me outstanding connectivity right now. So we can try to take the lecture on hotspot. If it goes good, then it's fine. If my voice breaks or if lagging is happening, then let me know. We're trying with hotspot right now. Okay. Chalo. Okay. Huh. So where were we? Operators. So I was saying that we can also apply operators on a bra vector also, just like a cap of psi. It can become a phi. And again, both the psi and both the phi are nothing but a conjugate of the ket vectors. No? They are the conjugate of the ket vectors. So both of them exist in the vector space. Okay, make note. You can also apply operators on the ket vectors also. There is no problem there.
So what is that sign? V type का?
It's just me only. It is just that capital V or small v में we don't understand. No? So I just write capital like this. Like whenever I write capital C and small c also, I write capital C like this. Like S also, I would write S like this, so that we understand the difference in capitals and small. Okay. Okay. So proceeding ahead. Next. हाँ sure. चल क्या रहा है ये तो बताओ, क्या भारतवासी?
सर गप्पे मार रहे थे हम। हाँ
अच्छा,
चलो।
okay. Okay. Nice. You don't get to do that often.
Yes sir.
सही है.
ये फर्स्ट टाइम है सर।
अरे first time. So this will happen more often.
No
Okay.
sir, no sir.
Okay. Proceeding ahead. Written?
Sir operator can sit behind that or right
हाँ
side
हाँ.
or left
Yes,
side.
basically on the right side of a bra vector and on the left side of a ket vector. This is just a convention. But when IITs are nobody is going to ask you convention. They are going to ask you the final answer. So in theory, however you write, it doesn't matter. Convention is it will be on the right of the bra and on the left of the ket. Yeah.
Okay sir.
Okay. And so I was also saying that. By the way, what is the use of operator? If you remember, I told you very clearly that wave function can be used to find everything in quantum mechanics. Wave function gives us the state of the vector. You can find energy, momentum, position, everything using wave function. How exactly? People, all these variables that we have, they are known as observables. This energy, position, momentum, etc. are known as observables. Variables, basically. All of them are variables. And each of them have their own, all of them have, each of them have their own operator. Each of them have their own operator. So energy has an operator, E cap. What is E cap? We will eventually learn, don't worry. Position has an operator, X cap. What is X cap? We will learn eventually. Momentum has an operator, P cap. What is P cap? Like how do we find P cap, X cap, E cap? We will learn. But the point is they have their individual operators. It means if you want to find energy of a wave, people, okay, all you have to do is you have to apply that energy operator E cap on the wave function psi, E cap of psi. The value that you are going to get on the right side, that will be the energy. If you want to find momentum, apply momentum operator on the wave function. The value that you will get, that's the value of the momentum. It's like just apply individual operators on the wave function and you get the result. People. Like I said, psi can be used to find everything. Wave function can be used to find everything. Okay. Individually, all of them, all the variables in quantum have their own operators. Okay. Chalo, next. Let's learn properties of operator. I'm going to the next page. Let me write it. There we go. Properties of operator. People, is voice good so far? Voice and clarity and everything?
Yes sir.
Chalo, nice. Because it's showing me nice, so good then. Great. So we have got the first property. A cap into B cap is into 5. Again, it's commutative, people. Sorry, not commutative, but it's associative. You are allowed to shuffle the brackets, people. So like you can first apply B cap of 5. Okay. And then whatever is the answer, multiply that with B cap. Multiply that with B cap. So whenever you have something like this, first you will calculate B cap 5. First you will calculate B cap 5, and then you will multiply that with B cap. Listen, sorry. In operators, listen. Okay. You cannot multiply the operators. I should take this question right now. I have a very good question on this. Listen. In operators, you cannot multiply the operators and then apply this. That will be wrong. If you are planning to do this, your associativity is not allowed. Okay. This is wrong. You cannot multiply the operators together. Otherwise, you'll get a very wrong answer. Yes. So and hence, if you have been always thinking, it's a shuffling bracket is so common. Why we were learning that A into BC? Because initially we felt that it was silly, right? That's why it can be always written as AB into C. No, people in operators you cannot write it that way. Operators cannot be multiplied together. Never. I will take an example right now, a very good example, a very popular example. So we have an operator d by dx minus x. It is d by dx into d by dx plus x. A very popular example. They have asked this in various entrances already. HCU, BHU, JNU, whichever people you will see, they have asked this question. They will ask you what is the value of this, and they will give you 4 options. Okay. Most of you are going to mark d square upon dx square minus x square, which is wrong. I'm telling you this already. Most of them are going to mark this side, so, and that is going to be wrong. I'm not sure if this will be wrong or not, but it could be wrong. Hang on, let me also think. D by dx. It probably is wrong. I'm not sure myself. Okay. Or I will take another example. So then what is the correct answer? Like I said, you cannot multiply the operators. These two are operators. Okay. So what you have to do? What is the answer of this? Okay, let's take this. So d by dx minus x into d by dx minus x. People, you always multiply operator on a function. So let's take a wave function and multiply this on a wave function. And I just taught you, first you will calculate this, then you will calculate this. Okay. So what do we have? D by dx minus x into, first you have to calculate this. Okay. So calculate now. D psi by dx minus x. Psi is a function. Psi is like people y. You can like f, whatever you want to write. 1 was plus, not this was plus. Yes, absolutely. Thank you. Okay. So psi is like y, x into y or f, whatever you want to write. Psi is just a function. I hope you are with me so far. Tell me if not. Okay. Now, again apply the brackets. So first term with the whole bracket, then second term with the whole bracket. Okay. So first term with the whole bracket minus second term with the whole bracket. Okay. So let's calculate what do we have. So this is equal to d square psi upon dx square plus. Now people, you have UB rule if you realize here. Derivative of x into psi. Now you have UB rule. First constant derivative of second, the second constant derivative of first. Okay. So x constant derivative of psi plus psi constant derivative of x. I hope you are with me. Tell me if not. Minus x into d psi by dx. Okay. Plus minus x into x is x square psi. Okay. What do we see? X d psi by dx, x d psi by dx cancelled. We have got d square psi upon dx square. Okay. Then we have plus psi, derivative of x with respect to x is 1 minus x square psi. People, if you take common, take psi common, take psi common. What do we have? D square x plus psi sorry. I hope everything. I'll just take psi common. I'll just take psi common. D square upon dx square plus 1 square plus 1 minus. People, compare the first.
Sir, your voice is
What do you see? You have an operator. Okay. Is the voice fine now?
Yes, sir.
Also try to speak some a little bit slowly and yeah.
Sure. Okay. So this operator into function is equal to this operator into function now. So equate the operators, people. You have got d by dx minus x into d by dx plus x. This is equal to what, people? Is it d square x upon minus x square now? You have got d square upon dx square plus 1 minus x. Which popularly minus x square? Which popularly is written as d square upon dx square minus x square plus 1. Many students would have marked only this now. Many students they would have marked only this, which is wrong by the way. Like I said, it's a common mistake that d minus b to a plus b is a square minus b square. No, people. In operators, it's not allowed. Operators cannot be multiplied directly. You can never multiply them. Answer is plus 1. By the way, this is popularly known as a raising operator. Raising operator, because you raise the value by 1. You raise the value by 1. As far as I remember, I'm not 100% sure about this. I'll just put a question up. I think it is known as raising operator because we get plus 1, and I think it is known as lowering operator if you get minus 1. I think so, as per my memory. But I hope you understood this. I will also tell you, I should have again. I have basically the past papers of each. In HCL somewhere, we have asked this question. Copy this. Ask me 20 questions. You're copying from here now. Just a second. This is a just 2013 question, people. The question that we just took, ditto. Exam ditto question, just 2013 question.
This question.
And answer is this question. This one, d by dx into d by dx plus x. Okay. And answer is option B of this, as per the PDF I have. Nice. Okay. I hope you understood, people. Now I think this concept will be hammered in your head. You cannot multiply two operators ever directly. Yeah. Similarly, you can check. I think so. The lowering operator would be the other way around. You know, like if you multiply this and this, I think you will get lowering in that case. Try that out later, not now. Did you copy this, people?
Yes, sir.
Okay. So do try. Take another example later and calculate d by dx plus x into d by dx minus x. Again, common mistake students would do a plus b minus b. That would be wrong. You know what you're supposed to do. Multiply with this wave function psi. Calculate these two first. Then calculate this with this. Take psi common at the very end. Cancel on both sides, and you'll get a good result. Whatever is the answer. I think in that case you'll get minus 1. But do check that. And probably it is known as lowering operator, not 100% sure. Clear? Shall we? So very good example to understand that associated bracket shifting is not always allowed because it's a common human tendency. Why brackets are important? Now we understand brackets are really important. Okay, so proceeding ahead. Let me try it. Next. Okay, second property, which is a cap, b cap, c cap. It can be written as a cap into b cap, c cap if you have 3 operators. Okay, and it can also be written as a cap, b cap into c cap. But you cannot shuffle them first. You cannot shuffle them. That's fine. So a cap, b cap is not necessarily equal to b cap, b cap. That is what you need to remember.
Yes, sir. There were lowering.
Right now, a cap, b cap is not. Okay, you got it? Lowering?
Yes, sir.
Okay.
Yes, sir. I get.
Okay, nice. So we are not sure whether it is called lowering or not, but basically there will be a minus.
Yes, sir. Minus 1.
Minus 1 is the question. Okay, so we have got a cap, b cap is not necessarily equal to b cap, b cap. Not necessarily equal to b cap, b cap. At times it will be equal, at times it won't be. So here commutative property is also not obligatory. Forget associative, forget the bracket shifting. AB, which is DA, which you always think is correct. No, here even that is not correct. Okay, I mean, maybe correct, it may not be correct. So for that we have a whole commutative algebra topic. But that's fine. Okay. Should I take a commutative algebra right now with this? A small idea. No, let me think. Like for example, we can check like I will define commutators later because we need operators ready for that. Leave it. Such a confusion. Next. Number 4. If we have a cap raised to m into a cap raised to n, then law of identity you can use. No problem. It is a cap raised to m plus n. Identities are fine. Number 5. 5 is not there. Sorry, 5 is already the third one which I wrote for you. Take note. Any questions? Anyone?
So number
Anywhere?
2.
Huh?
So when we are taking a function and we are taking that combination of that is combination of what can we say, operator onto that function, a cap, b cap, c cap. Then can we do that this way? First operated by c cap.
See,
then
what I will no, what I will always do, even though this is it, I'm stealing this from directly. Okay. What I would do is, to be honest, a cap, b cap, c cap. If I have a function, I'm never going to take risk. I'll first calculate this. Okay. Then I'll
Yes,
calculate.
I
and
must,
I'll-
yeah, yeah.
I will always follow this process. I don't want to multiply the operators if I don't trust that idea. Okay. My suggestion is always go with this. First multiply operator with the function, then whatever answer you get, then take the second, and then take the third. Okay. So next. We can, I mean, I'm not sure that whether this will be valid for T or not, we have written it, but unless we take an example and check, we can create our own example. You can create 3 operators, p by dx upon x, minus 1, then plus 1, and then maybe just third one d by dx, just d by dx, not minus 1 plus 1, not minus x. Create your 3 operators and see if this is valid or not. Like if this is valid, you can just check. I'll just write it here. Now you already know how to create examples. Okay. So for example, you can choose a cap is again the same, d by dx minus x. You can choose b cap is d by dx plus x, and just choose c cap as some random. Let's take d by dx, neither plus nor minus something, and see if at all this is true or not. Check this yourself. Okay. But in exam, my suggestion, like I said, always apply the operator nearest to the function first, calculate it, then go to the next operator, and then go to the next operator. Safest method. Okay. Chalo, next. So I would just write this as so a cap, b cap psi in exam it will give you. Okay. If you want to calculate this into psi, so basically first you calculate c cap psi, and now I'm putting a bracket here. Whatever is the answer, then I will go with b cap. Then I'm putting another bracket here. Whatever is the answer, then you will apply a cap. And now I'm putting another option. So this would be my preferred method. Okay. Because whatever relationship they give, I always prefer to check people. Yesterday, so beautifully we checked those quasi equality and triangular equality. Okay, it feels good once we verify them. So next is given linear operator. Linear operator. Okay. So people, a cap is called linear operator if a cap is called linear operator if a cap into a1 psi1 plus b1 let's say b2, whatever notations I can use a2 here. A1 psi1 plus a2 psi2 can be written as this can be written as you can, if we are allowed to throw the constants outside, a1 into a cap into psi1 plus a2 into a cap into psi2. Okay. If this is allowed to do, then we call it linear operator. This is also valid for ket vectors also. I mean, graph vectors also, no problem. Okay. So for example, you rotate for ket vectors, you can also write this for graph vectors also. How do we write this for graph vectors? Psi1 into a1 plus psi2 into a2. You have to multiply a cap. From right side, now remember for graph vectors, conventionally we will go this way. In some nobody is going to see that how you have got the result, but this is the convention. Okay. So that way, what we will get is first we can throw a cap on this, okay? And a1 you can throw separately. Similarly, a cap I can throw on psi2 and a2 I can keep it aside. Copy please.
So a1 constant है ना?
Yes, even into constants. Even into constants. ठीक है.
So derivative linear operator होता है. Derivative.
हाँ, absolutely. Derivative is linear operator because we always throw constants outside. Absolutely.
So you have written a cap is called linear operator if
Yes.
definition, right?
हाँ, it's a definition. It's a definition. So like he said, derivative is obviously linear operator because when you apply derivative, you can throw a constant outside the derivative, you know that. Okay, so derivative is definitely linear operator. Okay. Then people,
Yes, sir.
next. Okay. Hermitian operator. Hermitian operator. So people, what is the Hermitian matrix?
A dagger equal
A
to
dagger is equal to A.
That's it. Same. So a cap dagger is equal to a cap. Make a note. Okay. Dagger means transpose of a conjugate. Like dagger means transpose of a conjugate or conjugate of a transpose. Anything. This is conjugate of a transpose. You can also write transpose of a conjugate. That's also fine. Similarly, what is the skew Hermitian operator?
Minus A.
Minus. So a cap dagger is minus a cap. No, I mean your voice is breaking again. I'm not sure what is the problem from your end today. It's still breaking. A cap dagger is minus a cap.
So can you show a little example? That means dagger and operator can't understood. That means
हाँ मतलब like it depends on what kind of an operator we are having. Like for example, literally quantum will be using matrices, poly operators. So those will be our operators then. So it's matrix only basically. Otherwise, transpose doesn't make sense. Transpose means what? A row becomes a column and a column becomes a row. So see, if at all there is a row column idea, if at all the operator is matrix, just like we will be using poly matrices with quantum gate. So in that case, transpose will make sense. Otherwise, transpose has no significance. Otherwise, it's only conjugate. And conjugate we already know. So if I suppose for example, we have a momentum operator which we'll be learning eventually. It is minus I h squared rho by 2x, and the same factor will copy it. Okay? This is momentum operator. So what will be the conjugate of this? This I h squared rho by 2x. So dagger of this will also be same because there is no transpose significance here. So dagger will remain the same. Okay? Transpose is significant only when we have matrix. Otherwise, transpose has no significance. Rho can be converted to column in case of transpose. Clear?
yes, sir.
No problem. Tell me if you have any questions, please don't hesitate. Properties. Okay. Number 1. So A into A cap dagger. This can be written as. Now people, A is what? A is a variable. It's so again transpose for A doesn't make sense. A is a constant people. Transpose of it doesn't make sense. So when you apply dagger to A, don't you think it will be just conjugate? Transpose doesn't make sense. No? Conjugate of a transpose or transpose of a conjugate. So it will remain just conjugate. But A cap will become A cap dagger. Only if A cap is a matrix people. Again, if it's not a matrix, you can just, if it's a normal operator, you can just write conjugate also, it doesn't matter. Only if it's a matrix, it will become dagger. I hope you are getting. Second, dagger of a dagger, you get the same back. That's understandable. It's like conjugate of a conjugate. Third, a cap plus b cap plus c cap, the whole dagger. Okay. Again, you can just write a cap dagger plus b cap dagger plus c cap dagger. In addition, there is no order. In addition, it's fine. A plus b is b plus c. In addition, there is no problem. In multiplication, order is important. Okay. Fourth. But if your multiplication, in that case, yesterday only I had taught you, if you remember, that order is important here. Now you have to reverse the order. You have to write this as c cap dagger. I thought it doesn't matter, but here in diagonal order is really better. Okay. So multiplication order is important. Ask me if you have any doubts. Don't hesitate. All good people?
Yes, sir.
Shall next. Number 5. Also, a cap raised to n, and then you have dagger. You can interchange them. You can first calculate dagger, and even if after that you will take power raised to n, answer will be same. It's more like for a matrix again. It's like you have a matrix. You are squaring the matrix or cubing the matrix, and then you take dagger. Or first you take dagger and then square or cube the matrix. Answer will remain same. People. Answer will remain same. Okay. Number 6. A cap, b cap, c cap, psi. The whole raised to dagger. This will be equal to. Now you have to tell me how am I supposed to write it. You tell. It's not a property. It's basically a kind of a question. How should I write this?
C cap,
सर वेक्टर वो ब्रैकेट चेंज हो जाएगा कैट
First,
वेक्टर
yes, first cat vector should become bra vector.
यस सर सी कैप जाएगा बी कैप जाएगा ए कैप
Perfect. C cap, B cap, A cap. First, you will shuffle this and then you will shuffle the order. Good. C cap, B cap, A cap. All the orders people will reverse. Okay, all the orders. And dagger.
Dagger, sir.
Dagger. Tell me if you have any questions. Don't hesitate. Actually, you know, I was just asking that why this is called dagger.
yes, sir.
Dagger
This is like with dagger. That is handle, and actually the sign is the ending part is something long, and the upper part is something up. So that is one.
Yes.
Like a dagger.
Absolutely. Yes. Yeah, so it's more like a knife or something like that you are using. Dagger, you use to kill people. It's more like what do you call it in Hindi? Talwar, somewhat like that. So talwar has a shape like this. Huh? So you have something like this and then like this. Anyway, whatever. Proceeding ahead. Number 7. So suppose I would give you psi, phi, dagger. How would we write this? Take your time. Do it in your book.
कैट वेक्टर फाई एंड ब्रा वेक्टर साई
Perfect. Get vector phi and then bra vector psi. Okay. First you have to shuffle the order. That's important. So first you have to write phi and then you have to write psi. And then bra will become cat and cat will become bra. Good. Okay. Getting comfortable with this thing. Done, people. Next. Okay. Please be ready. Eigenvalues and eigenvectors. Eigenvalues and eigenvectors of operators. People, what is an operator? I already told you that. Huh? See, in quantum mechanics, we have a wave function. You can use a wave function to find every physical quantity. How? On that wave function, you have to apply a respective operator. If you want to find position, throw position operator. If you want to find momentum, throw momentum operator. Okay? So suppose you want to find momentum. So you will throw momentum operator on the wave function. Something reaction will happen, and you will get a result. Now that result represents an eigen equation under a condition, and you know the condition. Now. If you get the same wave function back along with just a variable equal, what is an eigen equation? So when you apply an operator, you have that this in matrix form. So if you apply a matrix on a variable x such that some reaction has happened and you get the same variable x again along with a coefficient. If you get the same variable again, in that case you say this is an eigen equation. But provided that you must get the same variable. So like for an example, if you write derivative of sin 2x, are you going to get same variable here? No.
No, sir.
What is this? This is 2 cos 2x. I'm not getting. So is this an eigen equation? No, this is not an eigen equation. But if I calculate people, second derivative of sin 2x now.
Yes, sir, minus 4.
So derivative of sin is cos, derivative of cos is minus sin. You get 2 to the 4, you will end up getting minus 4 at sin 2x. So it's like this is an operator. You apply this on a function. If you are going to get the same function back along with an additional coefficient, people, you call this an eigen equation. Now this is an eigen equation. Okay. So in this equation, d square x upon d square, this is known as an eigen operator. And this is known as an eigenvalue. And this is known as eigen function. Make a note, please.
सर -4 इज आइगन वैल्यू ना
हाँ, -4 is eigenvalue. पूरा absolutely. Along with negative.
So which function gives the eigen value? That is eigen function.
Yes. Wait, repeat the question.
Which function gives the eigen value? That is eigen function.
No. Basically, as far as any equation obeys this, if you get the same function back, it's an eigen equation, and then you know eigen operator, eigen function, eigen value.
Okay.
You should get the same function back. That's important. So, suppose you go to a salon, like the hair parlor. Scissor is cut in your hair now. Even after cutting your hair remains now. Is hair changed? No. So this is an eigen value example where scissor is the eigen operator, hair is the eigen function, remaining hair. That's your the hairs that were cut because you applied scissor. The hairs that were cut, that's eigen value. Whatever. As far as function should remain same. Okay. But coloring of hair, that is not example of eigen equation because obviously hair will be changed. You have color now, so no, that's incorrect. Just creating bakwas examples.
No, it's a good example.
सर ऐसे एग्जांपल याद रहते हैं सर
सही है. Okay, people. Proceeding ahead. Next. So basically in quantum, we will have an operator, we will apply that on the wave function psi1. Suppose this is ground state wave function, or psi3. Suppose this is the second excited state wave function. Second excited state, that will be 3. Okay, psi5 will be fourth excited state wave function. So suppose if you apply this on psi2, if you are getting psi2 back along with some value people, then what you can say, this is an eigen equation. Now understand what you just discovered. Like I said, in quantum, whenever you will apply operator on a function, you get the same function back. If that happens, this value, what is this value? This is the value that you found. You wanted to find momentum. Now, what did I tell you? Throw momentum operator on the wave function to get the same wave function back. Now, the value that you have, that is the momentum of the wave people, or momentum of the particle, momentum of the electron. So this A eigenvalue corresponds to the respective eigen operator eta. Corresponds to the respective eigen operator eta. So for example, if you apply energy operator on a wave function psi1, okay, so what you will get, people, you will get same if you get the same wave function psi1 again. If you get the same wave function psi1 again, then you will have some additional value here. This is the energy value. This is the energy value corresponding to this operator. So basically, you will get energy value. Okay, E will be energy value, energy of the wave people. Energy. This will be energy of wave function.
So basically, the eigenvalue depends on the operator.
I mean, yes, if you want to find energy, you will apply energy operator. If you want to find momentum, you will apply momentum operator. What are those operators that we will eventually learn? But yes, it will obviously depend on eigenvalue, has to depend on eigenoperator.
Sir, if cat vector change in Bragg vector, then
No, then also it's fine. I mean, you can write it this way. That is, I mean, doesn't matter. So this will be psi1, and you have E. This is also we can write, no problem.
okay, sir.
But it's very uncomfortable. I will go with the check of that. Okay, next. Okay, people,
Just a minute. Waiting.
take your time. Now I heard your voice properly.
So I'm a hotspot में था अभी तक. अभी आपका current आ गया.
Acha, okay.
Yes, sir. Please.
Okay, next. Very important note. For all the Hermitian operators, you may have learned this already. Do you know what happens to eigenvalues, people?
Real, always real.
For Hermitian operators, people, for Hermitian operators, eigenvalues are always real. Eigenvalues are always real. Please remember this. Okay. Next. And then people have also learned how to calculate eigenvectors. Okay. So, what is the meaning of an eigenvector? Let's understand in quantum. It will be better when we take an example, but thinking right now, if I can explain. Okay, right now, just like the note, we take an example and then it will be better. Right now, I just wanted to write this, that the eigenvectors, I hope you know eigenvectors, how do you calculate? It is always corresponding to a specific eigenvalue. Individual eigenvalue will have multiple eigenvectors. You know? So,
Yes,
like if you calculated lambda 1 and 3, then you calculate eigenvectors corresponding to lambda equals to 1. Then you calculate eigenvectors corresponding to lambda equals to 3. So, individual eigenvalues have their own eigenvectors. Important is that the eigenvectors corresponding to all eigenvalues are orthogonal. You know the meaning of orthogonal already. If you will take the scalar product of that, answer will be 0. Okay, that's important. And you can never realize it.
So need more clarification in eigenvectors.
So we can, what we'll do is in the next class, we'll take an example where we can calculate eigenvalues and eigenvectors. So basically, we are seeing how to calculate eigenvectors on that part.
Yes, sir,
Okay, we will take it because I want that in quantum anyway. So we'll take it.
thank you.
No problem.
So I have a doubt.
Bolo.
So why all two eigenvalues can be same, but the eigenvectors always must be different?
Two eigenvalues can be same, but eigenvectors must be always different. No, I have learned cases where we have got same eigenvectors too.
Okay,
But
sir.
we cannot.
Lecture has said it.
But no, if two eigenvectors. Okay, sorry. Okay, you are telling me basically if you have a lambda equals to 1 and if you have a lambda equals to 3, if you calculate this eigenvector and this eigenvector, then they should not match. That's what you are saying.
Yes, sir.
So they will not match because see, we just learned eigenvectors corresponding to all eigenvalues are orthogonal. Orthogonal means their product should be 0. If they are same vectors, then how can their product be 0? If they are same vectors, then the product cannot be 0. Then it will be 1 or maybe orthogonal, whatever. So yes, this statement is related to maybe what you are saying. See, why it happens? I'm not sure if I can give any exclusive proof of it, but by taking an example, we can understand. Like we can take an example, we can check eigenvectors, we can take products, and we can see that their product will be 0. Only that is how we can check. But okay, let's see if at all we will be taking an example later in the second half where if we are able to check this property, we can, no problem. Okay. So basically, people, suppose A1 eigenvalue gives you a corresponding eigenvector psi1. So let's write it phi1. A2 eigenvalue suppose gives you a corresponding eigenvector phi2, and A3 eigenvalue gives you a corresponding eigenvector phi3. These are the individual eigenvectors of the 3 eigenvalues. These are eigenvalues and these are eigenvectors. Okay. Then what is the meaning of this statement?
Looking at function.
Look,
That is
looking
get vector, na? Get.
these are ket vectors, but these are not psi vectors. These are not psi vectors. See, understand this. Lambda. You can get 2 lambdas or 3 lambdas. If you have a 2 cross matrix, then you get 2 values. If you have a 3 cross matrix, then 3 values. People, is my voice taking? Good.
Yes, sir. Sometimes.
Yes, sir, sometimes.
Sometimes. Okay, right now it's fine. I hope so. So if you have a 2 cross 2 matrix, then you have 2 values. If you have a 3 cross 3 matrix, then you have 3 values. But the values that you will have, suppose you have 2 values, lambda 1 and lambda 2. Lambda 1 will have its own eigenvector x1. It has nothing to do with this x1. X1 and x has no connection. Lambda 2 will have its own eigenvector value x2. Again, x1 and x has no connection. Okay. Clear now?
Yes, sir. So far.
We calculate x1 and x2 that I will teach you again later. No problem. There is a very interesting property that happens. Very interesting. I'm not sure if you're aware of this or not. People, these eigenvectors can be expressed as linear combination of
Yes, sir. Eigenvalues.
these eigen functions, these eigen functions, I mean not these, the eigen function, okay, x can be expressed as linear combination of eigenvectors x1 and x2. So you can write x as c1 x1 plus c2 x2. We can check this also later in the second half. So after this, as of now. As by the way, eigenvectors are also known as wait, no, nothing else. Eigenvectors are eigenvectors. Sorry. I can say it.
So all the products we are talking about, that is the dot product seems to be like.
Yes, comparatively to dot product. Yes. Similar to that. Okay, next. Proceeding ahead. How many properties did you write? 2 items. Yes, write down third one.
Sir, previous slide.
Previous slide, sure.
One previous.
So I was explaining this.
Yes, sir. Yes, sir. This is.
I was explaining. The eigenvectors corresponding to all eigenvalues are orthogonal. It means we have got eigenvalues, we have got eigenvectors. Now they are orthogonal means what? If you calculate phi 1, phi 2, answer will be 0. Orthogonal. If you calculate phi 2, phi 3, answer will be 0. It will keep on happening. Okay?
Yes, it is. Thank you.
No problem. Next. Proceeding ahead. Number 3. Eigenstates. Operator is okay. None of this is required right now at the moment. Eigenvalues are okay. These are metric properties. I don't want us to spend time in any of this now. Proceeding ahead just. Okay. So like you can learn infinite amount of properties. People learn Hermitian vectors and Hermitian matrix and anti-Hermitian matrix, or basically skew Hermitian matrix. Just search properties of Hermitian matrix and there are infinite properties. Somebody can like you can just find it on Wikipedia also. So these are completely useless right now, not really waste of time. Okay. Now please give me commutator algebra. Commutator algebra. Okay. So I've already told you people. So let me first define the meaning of commutator. The commutator of two operators A and B. The commutator of two operators A cap and B cap. Okay. Is how do we write this? Box of A cap B cap. And how do we calculate people? A cap B cap minus B cap B cap. I have already taught you A cap B cap are not necessarily equal to B cap B cap. We took that example also, d by dx minus x, d by dx plus x. If you shuffle them, answer is not equal. Okay. So basically this can exist. They are not equal. This can exist. Okay. So this is known as commutator. That's it. Simply this is known as commutator. Okay. Make a note. Now, so there is something called as anti-commutator also. The anti-commutator of two operators A cap and B cap is A cap comma B cap. You write it in curly brackets like this, and this is A cap B cap plus B cap B cap. You just have to write instead of minus, you have to write plus. This becomes anti-commutator. So by the way, I found that this is known as square brackets. This is known as curve brackets. This is curly brackets. Okay, square, curve, and curly. Okay, next.
So basically, these are the styles to express operator, no? Commutator.
Yes. Okay. Actually, eventually we will also find out that like you can express Heisenberg's uncertainty principle in the form of commutator and everything. This makes our life easy. Whatever we are learning right now, it is just like I said, language people that will be required. But you don't have to take any of these heavily. Just remember, whenever we are taking examples in the class, are you understanding the examples now? I think so far, whatever example you have taken, you probably must have found out them very easy. The derivative example we took, the normalization example we took. Yesterday also finding normalization constant. These are the kind of questions you can expect in exam. As far as you're finding the examples easy, be relaxed about the theory. Don't take the theory stressfully. I'm telling you this already. The only way to like learn quantum mechanics is believe that it's easy. Believing will reduce half of your job. If you don't believe, it will be very difficult. Just believe it's easy. Your job will be reduced by 50% then and there. Okay. And don't stress yourself in understanding the theory much. Just ensure when I take the examples numerical in the class, you understand that easy first. Okay. Next people. So two operators A and B are said to commute. If the commutator becomes 0 people. So this is basically that case where A cap B cap can be written as B cap, where they are by chance equal. They are not always equal that we already know. So basically, what is A cap comma B cap? What is the commutator of this? This is A cap B cap minus B cap B cap. No? This is 0. It means by chance, if they become equal, then you say that the operators commute with each other. Okay, then they commute with each other. But this does not happen always. This happens only at times. Clear, people? Like for an example, if I just want to take an example, very easy. Suppose d by dx comma 2. Whether this is these are the two operators, do they commute or not? If I want to find, how do we find this people? You have to apply this on the wave function. Don't forget that these are operators. Huh? If you want, you can write d by dx into 2 minus 2 into d by dx. But what after this? You have to apply operators on the function. But don't forget that. So apply this on the function. Okay, apply this on the function. So ab minus dx, and now show the function inside. So what do we have? D by dx of 2 psi minus 2 into d by dx of psi. And I've already told you how do we deal with this. First, wave function will be multiplied with the first operator. So 2 into psi is how much? Obviously 2 psi. Okay, 2 into psi is 2 psi. And then we will multiply this with 2x people. Similarly here also, first we will multiply psi with this operator, d by dx of psi. So this is d psi by dx. And then we will multiply. 2 is a constant I can put outside. So this is 2 d psi by dx. Okay, minus 2 d psi by dx. What is the answer? 0. It means d by dx and 2 commutes with each other. Simple. D by dx and 2 commutes with each other. I hope this example helps you to understand this better.
Yes, it is.
Commutes with each other. Done, people?
Yes, sir.
We'll take a break here. Making 15 minutes, joining at 45, 46, 47 maximum. Okay. Chalo. I hope you have copied that. If somebody's writing, no problem. Just leave it up at 15 minutes. Shall I end the session?